Hello students, today we are going to discuss some reasoning question, why question from the chapter Aldehyde, Ketone and Acids. Already I have told you when we are writing the reasoning question, we are writing the answer, giving the answer for why questions. You have to take care of the language what you are writing, and the answer should be to the point. It should not be more elaborate. Answer should be one sentence or maximum two sentences you have to write, because it is one mark questions. Briefly you write, and whenever any structure required during explanation, you have to draw the structures. Then it will be good impression. It will give good impression. Okay. So let us start the why questions of aldehyde, ketone and acids. We will start from last question. Question that is CH3CaCO does not show aldol condensation. Why this compound does not show aldol condensation? Already we have read aldol condensation mainly shown by the aldehyde or ketone having alpha hydrogen atom. As it has no alpha hydrogen atom, so it does not show aldol condensation reaction. This is the answer. Okay, it has no alpha hydrogen atom, that's why it does not show aldol condensation reaction. It's very important. Then question number 19. Sodium bisulfite test is used to separate aldehyde ketone from the mixture. When the mixture organic compound is taken for the separation, we can use sodium bisulfite test, because we know sodium bisulfite test produce a pure bisulfite salt. Aldehyde and ketone convert to aldehyde, ketone will convert to sodium bisulfite salt. It is convert to sodium bisulfite salt. As it is convert to sodium bisulfite salt of aldehyde and ketone, and which will be separated in the form of precipitate, white precipitate. So it will be easy to separate aldehyde ketone from mixture, because it produce pure sodium bisulfite of aldehyde and ketone. No other mixture will be there. That's why it will be separated from the mixture in the form of sodium bisulfite salt. That's why we can add sodium bisulfite to separate aldehyde ketone from the mixture. Then question number 18. Acids exist in solid or liquid state. Generally, acids, carboxylic acids available in solid state or liquid state. Why? Carboxylic acid available in solid state, liquid state, because that carboxylic acids have strong hydrogen bonding. If you see, it has strong hydrogen bonding. Due to strong hydrogen bonding between the carboxylate group, this carboxylic group has strong hydrogen bonding. Due to strong hydrogen bonding, it exists in dimeric form. That's why the molar mass increases. When the molar mass increases, the van der Waals force increases. That's why they exist in solid state or liquid state. So this is very important questions. Why they available in solid state or liquid state. Formic acid is used as a reducing agent. It acts as a reducing agent because it has formic acid with CH bond. This CH bond is weaker bond. That's why this sigma bond sigma bond CH bond is weaker bond. That's why it can be acts as what? A reducing agent. It reduces other salts like Fehling solution, salt solution, Fehling solution, tolerance reagent. It reduces. Formic acid reduces tolerance stage in a ferric solution because it acts as a reducing agent due to availability of weaker CH bond. Okay, this is the answer. Benzoic acid produces meta-substituted electrophilic substitution reaction. ESR means electrophilic substitution reaction. Why? Benzoic acid shows this one. If you see the resonance structure of benzoic acid, if you draw C double bond OH and like this, in the first step what happens? This is the reaction towards carboxyl group because it is a withdrawing group, so it produces partially positive at ortho position, and also it produces partial positive at para position. As it produces plus in ortho position and para position, so in next electrophile prefer to attack at the meta position because meta position is more electron density than ortho para position due to resonance of COH group with the benzene ring. Because acid group is the electron group, it withdraws the electron from the benzene ring and produces partial positive. It produces electron deficient nature at ortho para position. That's why electrophile attack at meta position. This is the answer. Then question of 15. Carboxylic acids show abnormal molar mass in water and benzoic acid, benzene medium. Generally, carboxylic acid in water it shows lower molar mass, but in benzene shows higher molar mass compared to normal molar mass. Now, compared to normal molar mass, molar mass changes due to association and dissociation. Carboxylic acid in water undergo dissociation, that's why molar mass decreases, but carboxylic acid in benzene shows association like this structure, hydrogen bonding structure, dimeric form. That's why almost in benzene the molar mass of carboxylic acid become double because due to dimeric formation of carboxylic acid due to hydrogen bonding. That's why shows abnormal molar mass. Deviation in molar mass. Molar mass decreases in water medium but increases in benzene. This is the explanation why it shows abnormal behavior due to association and dissociation. Carboxylic acid has higher boiling point than aldehyde ketone because it has strong hydrogen bonding, intermolecular hydrogen bonding, exists in dimeric form, having greater molar mass. That's why the boiling point increases. Benzoic acid does not give Friedel-Crafts alkylation or acylation because benzoic acid forms salt with the ferric chloride. Or aluminum chloride. If you use ferric chloride or aluminum chloride, then it produces salt with which one? Benzoic acid. As it produces salt with the benzoic acid, that's why it is a electron acceptor. That's why it cannot show Friedel-Crafts alkylation acylation reaction because it produces salt. Benzoic acid does not show nucleophilic substitution reaction like aldehyde ketone. Like although let me remove this one. Benzoic acid does not show nucleophilic substitution reaction like aldehyde ketone. Nucleophilic addition, not substitution, nucleophilic addition reaction. This addition, nucleophilic addition reaction like aldehyde ketone. Why it does not show? Because if you see the structure, benzoic acid structure like this, it has resonance. If you see structure like this, so it loses double bond character. Keto group, the free keto group is not available in benzoic acid due to resonance. As it has resonance, it loses a double bond character of keto group. As it loses double bond character of CO keto group, that's why it does not show nucleophilic addition reaction. Does not show nucleophilic addition reaction because it loses the double bond character of keto group in benzoic acid. That's why it does not show the reaction like aldehyde and ketone. Okay, then Question number 11. It is necessary to control pH level of solution when nucleophilic addition reaction of aldehyde ketone with ammonia. We know nucleophilic addition reaction takes place of aldehyde ketone with ammonia and ammonia derivative. But why we have to use a particular pH level? Because if the pH will be decreased, that means in highly acidic medium, what happens? It loses. Suppose aldehyde or ketone if you take in highly acidic medium, what happens? This ammonia will react with H plus, forming ammonium salt. As it produces ammonium salt, so loses the nucleophilic character. The nucleophilicity character of ammonia will be lost due to addition of H plus in higher acidic medium due to formation of salt. That's why it cannot be used as a nucleophile. Generally, ammonia and ammonia derivative used as a nucleophile in nucleophilic addition reaction of aldehyde ketone. But when you use a highly acidic medium, then ammonia will be converted to salt. So it cannot be used as a nucleophile. This is the answer. Then question number 10. Acid halide is more reactive than alkyl haloalkane towards nucleophilic substitution reaction. If you see nucleophilic substitution reaction, why RCOCl is more reactive than RCl? What is the cause? Because here if you see, here what happens? This is your what? Structure of acid halide, and this is the structure of that alkyl haloalkane and acid halide. Then what happens? Here if you see nucleophilic substitution reaction, if you see the partially positive charge, the partially positive, that is RCO is more reactive than RCl towards nucleophilic substitution reaction. It is more active because if you see it has pi bond and electronegativity oxygen towards in this reaction. So the partial positive charge will be the more partial positive charge developed compared to this R, because here what happens, this C is more partial positive because the oxygen is more electronegative and it has weak pi bond is available, and oxygen is more electronegative, and oxygen is more electronegative. As oxygen is more electronegative and availability of pi bond, weak pi bond, that's why it is more reactive than haloalkane. So acid halide is more reactive than haloalkane towards nucleophilic substitution reaction because presence of weak pi bond and more electronegative oxygen. That's why carbon will be more nucleophilicity towards for the reaction of nucleophile. So this is the answer. Okay, question number 9. RCOCl is easily hydrolyzed than benzoyl chloride. You compare to benzoyl chloride, RCOCl is easily hydrolyzed. If you see the structure, that this is the structure of your acid halide and this is the structure of your. So here what happens? Why the RCOCl is easily hydrolyzed than benzoyl? Because what happens here? That the carbocation produced will be the partially positive charge. This charge will be neutralized by resonance. That's why the reactivity that it cannot be hydrolyzed easily due to formation of pi bond with the keto group. And here what happens, if you see Here both plus effect and minus effect in one direction. Both are in one direction. Here R is a plus affecting, it is facilitating the breaking of Cl bond. But here what happens? This due to, or we can see this group is electron, or you can other structure you can draw that. And this group electron withdrawing group, phenyl is electron with minus effect. R is a minus effect, but it is a plus effect. That's why CCl bond breaking will be here. It is facilitated. R facilitated the breaking of CCl bond, but phenyl group due to electron withdrawing group, it obstruct the breaking of Cl bond. That's why if you see the polarity, CCl bond is more polar than CCl bond of benzoic acid. That's why the benzoic chloride is less hydrolyzed, is not easily hydrolyzed unlike acid halide. This is the answer. Only difference is it has plus effect and minus effect in same direction. That's why polarity CCl bond polarity increases. But this case CCl bond polarity decreases. HCl cannot be used in the preparation of RCOCl from acid halide because same already discussed. Here what happens? Due to double bond character of COH bond, Cl cannot be used as nucleophile. HCl means Cl minus cannot be used as nucleophile for breaking of COH bond. Due to resonance, it gets double bond character. That's why it cannot be substituted by Cl minus directly. That's why HCl cannot be used in the preparation of acid halide from acid directly because it forms double bond with the benzene with the keto group. That's why COH bond strength increases. It cannot be replaced by Cl minus. Ester or water must be removed from the mixture during esterification so that the reaction will be faster. For example, you see the structure that if you see that acid and alcohol in presence of acid produce ester and water. And this reaction is reversible. As the reaction is reversible, if you remove either water from the mixture or ester from the mixture, so equilibrium will be towards forward direction, more amount of ester will be synthesized. That's why as per the Lynch-Adler principle, as is a reversible process, if you remove the amount of product from the mixture, then amount of product will be increased. So as per the Lynch-Adler principle. So this is the answer. One nitrogen is more reactive in the reaction of semi-carbohydrate and aldehyde ketone. Only out of 3 nitrogen, 1 nitrogen is more reactive. If you see the structure of semi-carbohydrate, that NH2, CO, NH, NH2, this is the semi-carbohydrate. But out of 3 nitrogen, which nitrogen will be more nucleophilic compared to others? Because here keto group is a electron withdrawing group, the electron density on the nitrogen adjacent to CO group is less. So the last nitrogen will be more electron density, have more electron density, that's a better nucleophilic character compared to, it will be better nucleophile compared to other 2 nitrogen. That's why out of 3 nitrogen, 1 nitrogen is more reactive compared to other 2 because this last nitrogen has more electron density because it is away from the keto group. This is the answer. But structurally you have to explain. Whenever you are writing the answer, you are writing the why question, better you draw the structure and give the language so that it will be more it will give better satisfaction to the examiner, so that instead of writing language, better write language and structure. Then 2,2,6-trimethyl cyclohexanone is less reactive than cyclohexanone. If you see the structure, just 1 minute. 2,2,6-trimethyl cyclohexanone is less reactive than cyclohexanone. 2,2,6-trimethyl cyclohexanone, if you draw the structure 2,2,6-trimethyl cyclohexanone, here what happens? This bulkier group attached to the keto group. So keto group is sterically protected by 3-methyl group of 2,2,6-trimethyl, but cyclohexanone is free. Cyclohexanone is free to attack by nucleophile. So nucleophile can easily attack to this position because it is free. But here this 3-methyl group, bulkier group attached to keto group, it obstruct the incoming nucleophile. That's why keto group is sterically protected by methyl group for attacking nucleophile. That's why the reaction is slow. Generally, it does not show the reaction because it is sterically protected. Aldehyde is more reactive than ketone. Very simple answer. Why aldehyde is more reactive than ketone? Same type of answer you can write. Here aldehyde, what happens? The keto group is sterically protected by bulkier alkyl group. But here aldehyde, one H smaller group is there. That's why nucleophile can easily attack to keto group, carbon atom of keto group. Here the carbon atom of keto group is sterically protected by bulkier alkyl group. That's why it is less reactive and aldehyde is more reactive. Fluorobenzoic acid is less acidic than benzoic acid, although it is electronegative. But why it is less acidic? Because very simple answer. Fluorobenzoic acid, if you draw the structure, what happens? This is the structure of your benzoic acid. In fluorobenzoic acid, what happens? Due to the resonance, due to the inductive effect, the electron density towards the oxygen increases. Due to that plus R or plus M, due to plus R or plus M, to the presence of fluorine, so electron density toward oxygen increases. That's why it is less acidic. You cannot lose H plus ion easily. But in case first you see fluoroacetic acid is more. Here the answer is just opposite. In case of fluoroacetic acid, what happens? Here no resonance, such type of resonance takes place. Only minus I effect is more in case of fluorine. Due to more electronegative, fluorine is more minus I effect than fluorine. That's why fluoroacetic acid is more acidic than fluoroacetic acid. Very important question. Repeatedly I am telling. Please write down. Fluoroacetic acid is more acidic than fluoroacetic because fluorine is more electronegative than fluorine. But in case of benzoic acid, when fluorine is substituted, just opposite. Because fluorine is small size, it forms plus R with the benzene. That's why electron density around oxygen of acidic acid of the carboxylic acid group increases. That's why H plus cannot be easily released. That's why just opposite. Fluorobenzoic acid is less acidic, but fluoroacetic acid is more acidic. Only here answer is minus effect. Here answer is plus R favor. More plus R is more. Due to more plus R, electron density oxygen increases, so loss of H plus will be slow. Then acetic acid is more acidic than phenol. If you draw the structure of acetic acid and phenol, if you draw, but if you compare the conjugate base of acetate ion, this is the conjugate base and phenol ion. Although it has more number of resonance, it has less number of resonance structure, but it is more stable than this one. If you compare the stability of acetate ion and phenolate ion, it is more stable due to equivalent resonating structure. Equivalent resonance. Equivalent resonance means same type of resonance structure developed due to delocalization. But although it has more number of resonance, but it is not equivalent resonance. Already we have read characteristic of equiresonance. If the particular structure has equivalent resonance, then it is highly stable. So acetate ion is more stable than phenolate ion due to equivalent resonance. That's why acetic acid is more acidic than phenol. Although phenolate ion has more number resonance, but stability is less compared to carboxylic ion due to equivalent resonance. So this is the answer. So this is regarding the some important why question of from chapter aldehyde ketone acids. You practice more. Any doubt if you have, you can ask me, we can discuss in the next class. Okay, thank you.